All right, the next example here, we're going to be talking about inverse trig functions. Now, you may look at this and say, this is not anything that I want to read, and you really don't have to. All that you need to know about an inverse trig functions is that it cancels regular trig functions. What do I mean by that? Well, just like any kind of operation, for instance, division, if I want to get rid of it, what do I use? I use multiplication. So for instance, if I have x divided by 5, how do I get rid of that? Well, I multiply it times 5. That cancels out both of these 5s, and I'm left over with x. So in the same way, if I have something along the lines of, let's say, sine of 24, how do I get rid of that sine? Well, I'm going to use a sine inverse function, which means that I'm going to apply to the outside of this sine inverse. And I show that with a -1 in the superscript. Now, this is not to the power of -1. This is just denoting that this is an inverse sine function. So now that I have a sine and a sine inverse, this sine and sine inverse cancel out, and I'm left with 24. So that's what sine inverse functions do. Don't worry too much about that. We're going to get into example and use a sine inverse function. So for instance here, we want to find both of these angles. It says find the measure of each angle and round to the nearest tenth if necessary. So first of all, we're going to go ahead and find our L angle. That's going to be this one right over here. We're going to say that this is going to be our theta. Now, how are we going to do that? First, we again need to write out our SOHCAHTOA. So SOHCAHTOA. SOHCAHTOA. Now, if we're trying to find this angle right here, which is L, we have two bits of information that we can glean from. We have the 6 and the 10. Now, the 6 and the 10, what are they? Well, according to this angle, the 6 is going to be adjacent to this. So we're going to say ADJ. And the 10 is going to be the hypotenuse. So we're going to say HYP. So if we're trying to find this angle and we have the adjacent and hypotenuse, we're going to use cosine. As we know, cosine of theta equals adjacent over the hypotenuse. Therefore, cosine. Now, do we know the angle yet? No, we don't know the angle yet. So we're just going to keep that as theta. And then inside, I apologize. Sweet. All right. So we have cosine of theta, and we don't know what theta is yet. So that's going to equal something. That's going to be adjacent over the hypotenuse. Now we know what the adjacent is. That's going to be 6 over the hypotenuse, which is 10. Now, what do we do to figure out our theta? Theta here is like a variable. It's just some kind of letter that shows that we're trying to find that thing. So right now, theta is not by itself. How do we get rid of that cosine? We just learned about these things. We have to apply an inverse trig function. So I move that over a little bit, and we're going to apply our inverse trig function. We're going to say cosine inverse. This cosine inverse will take away that cosine. And on the other side, anything we do to one side, we have to do to the other. So on the other side, we're going to also say cosine inverse of this guy right over here. So what does that do? Well, the cosine inverse and cosine on that side cancel out. On the other side, it's just going to be a mathematical function. So let me show you what that looks like. theta is going to equal the cosine inverse of 6 over 10. So what we can do is just type that into our calculator and we should be fine. So let's do that. All right, as you can see here, what I typed in was cosine, and then I said to the power of -1. It's going to treat it the exact same way as a cosine inverse. It knows that you're not actually saying to the power of -1. So our missing angle is going to be 53.13 degrees. Another way that you can actually type this in is that if you click on one of these boxes and pull up the keyboard that's provided by Desmos, at the far right, you'll see that something that says functions. Now, here with functions, you have trig, statistics, uh, whatever this is, and miscellaneous. Now, in trig, you'll see all of the functions right over here. These come up in calculus too, so don't worry about those things. But here we have cosine inverse. You would just click that and still type over. Then you would still type in 6 over 10. But we've already done it, so that's our answer right there, 53.13. Let's use that. So here, our theta is going to be So here, our theta is going to be equal to 53.13. And we are done. Except we still have one more angle because we're able to find this angle right over here. I'm just going to say that this was 53.13. And now we need to find this angle right over here. And you might say, oh man, we have to do that whole thing again. And the answer is you can if you want to, but you don't have to. Because we have to remember that all the angles in any triangle is going to equal 180 degrees. And since we already have two of them, we know what the last one is going to be. So if we take 180 degrees, we take away this 90, we take away this 53.13, that's going to be 180 minus 90 minus 53.13. And this is going to equal 36.87. This is our last angle. So we have a completed triangle now. Here would be 53.17, and this would be the 36.87 that goes right there. I'm going to draw a little arrow that shows that, hey, that's that angle right over there. All right, let's try out this next one here. This is question B. Now, we're going to choose one of the angles to find because we have to find one, and let's choose A. Why not? We're going to call angle A. That is going to be our theta. Based on this angle, we have to choose our trig function. Let's label our sides that we know first, and then we can choose our trig function. Well, this 8, if we look at it, we can draw an arrow across the triangle to get to it. Therefore, this is going to be our opposite side. 16 is very obviously going to be our hypotenuse. Now we have everything we need to know to choose the trig function. What deals with opposite and hypotenuse? Well, that is our handy dandy sine. We're going to use sine. So we're going to say sine of theta, or we're going to say sine of theta is going to equal opposite over the hypotenuse. The opposite is 8. The hypotenuse is 16. If you want to, you could simplify this down to 1/2, which I did. Now, we want to get the theta by itself because that is the angle that we're trying to find. How do we get rid of sine? Well, we're going to use a sine inverse function. Let's do a sine inverse to both sides. We're going to say sine inverse on this side, and we're going to do a sine inverse on this side as well. On the left side, the sine inverse and the sine both cancel out, so now we are left with just theta. And over on the right side, we're left with sine inverse of 1/2. Well, how do we get this sine inverse of 1/2? That is something we can just type into our calendar. And when I say calendar, I of course mean my calculator. So let's type in sine inverse. Let's go this route this time. Functions sine inverse, and we're going to say 1 divided by 2. This is going to equal 30. Look at that. So let's go back to our problem, and we can just fill it in. We can say, all right, well, theta is going to equal 30. Super nice, super simple. And then we can fill that in on our triangle. We can say, hey, this angle is going to be 30 degrees right there, that one. Now, to find our last angle, we don't need to do this again. We can do this again if you just want the practice, and by all means, get the practice. However, all we have to do is just add up our angles and say, oh, they're going to equal 180 degrees. So let's take 180, and we're going to subtract the 90 that we know is right here. And we're going to then subtract the 30 that we also know is there. And that is going to give us 60. So that's going to be 60 degrees. I'm just going to box that off for anybody looking at this later. And that angle is going to go right here. So now we have both of the angles that we need. Now I want you to try the practice problems down here. Give this a shot, and I want you to pause the video. And if you get stuck, rewind to see how we did the previous examples and then apply that to this. So I'll let you pause the video right here. Now, I know that you paused the video because you are good students, so let's do this together. First, and always first, we write our SOHCAHTOA up here. SOHCAHTOA, SOHCAHTOA. And we're going to find that angle that they give us right over there. This one, we don't have to find all of the angles, we only have to find x. Now, this is going to be the same thing. You can do two things. Either you can relabel the x as theta, or you can just use x. In this example, we're going to use x. That way we get the practice of using a different variable. But first thing is first, and we need to know what trig function we need to use. So in this case, let's label our sides. This 15 looks like it's connected to this angle that we're trying to find. So this is going to be our adjacent side. 17 is going to be our hypotenuse. Now that we have labeled our triangle, we're going to identify what is the proper trig function to use. We have adjacent and hypotenuse. So let's look at our SOHCAHTOA and see which one deals with adjacent and hypotenuse. It looks like cosine does. So let's use cosine of x. We're going to say cosine of x is going to equal 15 over 7, which of course is the adjacent divided by the hypotenuse. And those two values are labeled right over here. Now, we want the x isolated. We want our angle. That is the thing that we're trying to find. So we are going to take the inverse of cosine on both sides. We want to get rid of the cosine, so we're going to use our cosine inverse function to get rid of it because that's what it does. But It is going to cancel out the cosine on the left side, leaving us with just x. And on the right side, we have cosine inverse of 15 over 17. All we have to do is type that into Desmos, and it gives us our answer, which is 28.1. So that missing angle is 28.1. Looking at our 5b example over there, we want to do the same thing. We want to find that angle x measure. Now, we have two sides which we should label, so let us label them. 27, if you look, it seems like we can draw an arrow going across the triangle to get to 27. So that, of course, is going to be our opposite side. Now, what about 18? Well, it's not our hypotenuse. We know because our hypotenuse would be opposite of that 90-degree angle. 18 would be our adjacent side. So now that we know that we're dealing with opposite and adjacent, which trig function do we use? Well, looking at our SOHCAHTOA, tangent is the one that deals with opposite and adjacent. So we're going to write out tangent of x equals 27 over 18. Opposite being 27, which is labeled, and the adjacent being 18, which is also labeled. So now we need to get rid of our tangent because we want the x by itself. How do we get rid of tangent? We use our tangent inverse function. We're going to perform that on both sides, and of course it's going to cancel out on the left, where on the right it's just going to be a function which we can type into our calculator. So once we do so in Canvas, and by Canvas I mean our calculator, we are going to get 56.3 degrees. So if we look at our triangle over here, this angle right here is 56.3 degrees.